Good afternoon. Okay, good afternoon, everyone. I'm Martin Howrlack. I'm a second-term state representative representing Troy and Clawson. And just a few remarks I want to make, but to my friend Jeff Bradley from Illinois, there was a period of time from 79 to 84 when I lived in West Virginia, and so I know all about coal country. And as a kid, I used to think that all men eventually got black lung. And it's interesting, as a child, the perspective of the world is the world as you know it. And so for me, at that time in West Virginia, everybody I knew had an uncle or a dad who had black lung. But of course, that's not the way it is, and I just knew that I wasn't looking forward to getting black lung, and hopefully I won't, since I never worked in the coal mine. I think it's important to, when we talk about things that impact people, to understand that behind each face, there's a person. And with each person, there's a story. And with each story behind that person, there are different perspectives. You know, these are not just, when you look at somebody in prison, these are not just animals. These are people, like you and me. And they're there because of life experiences, for whatever reason they may be. And I must tell you, my own life experience, I never in my wildest imagination would have thought that my policy areas in the legislature would have gravitated towards juvenile justice, criminal justice reform. I mean, I'm an accountant. I also have a geological background, so I have an engineering interest. And, you know, I know a lot of fiscal issues. And I did a lot of fiscal work when I was on the city council in Troy. But what I find, and what we find in life, is that if there's a need and we can fulfill that need and we don't place ourselves in that void, then that void will continue to exist. In other words, there's a policy need in these areas, and there are a few of us, including my good friend Representative Santana from Detroit, who are working now in these policy areas. And we're there because nobody else is. We're there because we are interested and passionate about these issues. The challenge that we face is that there's no easy and quick solution. In other words, the work that Representative Santana and I are doing is only a part of what needs to happen. The solutions are long. The solution will take a lot of time. The solution is more than simply creating laws that prohibit the placement of youth in prison. It's about changing the culture. You know, why is it that youth who are born into a certain community, for example, end up in prison more than youth in other areas? I can tell you that I was blessed because I had a very peaceful and serene life. I lived in a safe environment all 18 years of my youth. I had parents who were engaged in me. Quite frankly, the first B I got was in cursive, and I was scared to death of what my parents would think. And I'm like, this is the worst that I had to experience was the fear of the wrath of my parents for, you know, not doing a good job. But what if you don't have those parents that are engaged in your life like that? And what if you live in a community where things are not so peaceful and you don't have opportunities? So what I mean is, there's a culture, there are opportunities that are not present to everybody. And even though we say that education is a right and something that everybody has access to between K and 12, what kind of education are people getting? What about mobility? You know, if you have jobs where people can't get to those jobs. I've got jobs in Troy, but I got people outside of Troy that want to get to those jobs, but it takes them an hour and a half to get there by bus. What if they can get themselves an automobile, but they can't get on the bus? But what if they can't afford the insurance to buy that automobile or the gasoline to get in that automobile? So, it's, you know, if you take people into the prisons and you rehabilitate them, you also need to make sure the opportunities are there for them to actually put food on the table and to make a living of it. And I'm not talking about handouts. I'm talking about opportunity. I'm talking about fairness and equity. I'm talking about justice. So here I am in the legislature working with Harvey Santana. And by the way, after I looked up Harvey's district when I was a new legislator, it turned out that I knew his district more than he realized I knew his district, because the first woman I was courting, who I was very serious with, in other words, you start to think about marriage and those sorts of things, actually lived in what's now his district over there, Retirement in Schaefer. And I told Harvey, I said, I remember I drove to your district many times, and the speed limits in Detroit are different than the speed limits in Troy, because when they say 40 in Troy, they mean 40, but when they say 40 on Schaefer, they mean about 65. And he says, I know exactly what you're talking about. I said, but, so I know Harvey Santana's district, but I don't know the things that people in his district face, because in my sheltered life, as it were, my experiences with his district was an adult, and I could fly in there and out. But I can tell you that my girlfriend at the time had to experience a lot of challenges in her life because of that. At any rate, so my point here is that we have work to do in the legislature. The legislature is ephemeral. You have people coming and going. And so you have people looking for quick fixes. Unfortunately, the fix is not quick. The solutions or the challenge is real. And so what you need to do is create in place a system. And so we may not necessarily succeed in a system and a dialogue. So we may not necessarily succeed in everything that we are setting out to achieve in this term, but don't be disheartened by that. It's a long journey. We need to keep the dialogue, and we need to make sure that we have people that are in the first or second or third term in the House and the Senate, in the Democrat and in the Republican parties, that are interested in these issues so they can continue that march. It's a long journey, but we need to actually look at the end here for where we're heading. And so they told me I have 2 minutes, and the problem is, and believe it or not, I was a shy child. But I want to leave you with this, especially when it comes to youth. And the older I get, the more I realize that I wasn't nearly as wise as I thought I was as a youth or even as a young adult. But think about this. Think about how it is that we remedy people that make poor decisions. And so I'll give you this as an example. On my mother's side, I had a self-taught Italian grandfather, very smart man, terrible with bookkeeping and details. But he had he was in Pittsburgh, and there are a lot of Italians in Pittsburgh. He had a garage. He fixed cars, and if you wanted good quality work, you went to my grandfather Art. He wasn't the cheapest. You might even forget that you hadn't paid him yet, but he did really good work. And so there was my mother and her 2 younger twin brothers. And there was a neighborhood boy that was always kind of coming around and doing mischief. And he was younger than my two uncles. And so what they did was they gave him, they basically, they chased him away, and they basically gave him an ultimatum. They said, either you shave up and, we'll take you under our wing, or, we're going to beat you up and you might end up, facing the law. And so, and the truth is, he had done some crimes. He had done some vandalism. But this gentleman ended up being mentored by my uncles and coming under the tutelage, if you will, of my grandfather, shaped up, and ended up, quite frankly, becoming a self-made entrepreneur. He's very wealthy now and is employing many people in well-paying jobs. What would it have done if we had simply seek justice for him and sent him away to prison? And so, again, we need to make sure that we protect our communities and maintain their safety, but there's a fine balance between justice and correction. And there's a reason why the DOC is a Department of Corrections, is because our intent, our long-term intent, is, if possible, to correct people's behavior and to return them to society as best as they can, so they can become productive members of our society. And the best opportunities to do that are when people are younger. And so we have an opportunity with youth, including youth who get in trouble, and youth that, quite frankly, do need to have some punishment. We have the opportunity to reform them so that they can become productive members of society, and so they can actually go to youth who are getting into trouble and mentor them so that they become productive members of society. And so when they're at that fork in the road, they will turn right and stay on the main road. And if they get off that road, they can be brought back onto the road before it's too late. Because we have opportunities in life to do the right thing until our life is ended. And so as policymakers and as people in government, we need to make sure that we give people those opportunities. And so that's why I'm here, because the status quo is not sufficient, and because from an engineering perspective, we need to actually be involved in continuous improvement when it comes to policy. And so we have something that's broken, and I can assure you, there are no quick fixes. Harvey Santana and I have some solutions that are going to help remedy some of the problems. Again, he and I are under no illusion that we have all of the solutions. We're going at our first bills that we're going to introduce are necessarily perfect bills. We have to start somewhere. So thank you very much. I look forward to continuing this journey with you, at least for the next 2 years, and even when I'm outside of the legislature, I will continue that journey with you as well.
Good afternoon. My name is Esther Onaga, and I'm with Michigan State University. And it is really a marvelous time here today for me to see what collaboration can bring. We offer the Family Impact Seminars to policymakers, and this is the biggest crowd I think we have our speakers talking to. So thank you very much for being part of the audience today on a very timely and important topic. The Academy, unfortunately, I think, and the people downtown here really live in two different worlds. And today is a way to get us in the same room, to get to meet one another and see what we can do as a community. The Family Impact Seminars are offered in 24 states across the country, so we're not the only ones. And this is our mission, to bring research in a timely fashion on topics that legislators think are going to be important topics coming up. So today we have two Michigan State professors here, and I'm thrilled to say that we're bringing the best of our minds on brain research to offer you their knowledge and to use that knowledge in your deliberations about where Michigan should go. Our first speaker is Dr. Lori Hoisington, and she's from my department, Human Development and Family Studies. But she has a really interesting background. Her professional career is in clinical healthcare. She received a degree in radiologic technology, most unusual in the group of faculty that I'm with. And she has a degree, a doctoral degree from our department. She did research on functional brain imaging, and she understands the interpersonal interaction that accompany brain activity. And today she is an instructor and advisor to our MSU students. The second speaker is Dr. Cheryl Sisk, and she is also at Michigan State University. Her degree is from Florida State University, and she has had many major universities as her employer. Northwestern, University of Texas at Austin, and finally Michigan State University. We are very lucky to have her. She has received the Outstanding Woman Faculty Award from MSU. She's a distinguished faculty at Michigan State University, and she has received the Faculty Award from the MSU Neuroscience Student Council. She's received money from National Institutes of Health as well as National Science Foundation. We are very fortunate to have two scholars here who will give us an understanding about what is going on with brain research. The final thing that I will ask of you, and I feel like I'm being really pushy on this part, is that our lifeblood for continuing our work is accountability on what we do. And so these green sheets, I should be wearing green and white today, but These green sheets are evaluation forms, and I hope you would fill them out. And we have people back there, Jamie and Erica, who are going to dog you for these sheets. And this way we can hold ourselves accountable to what we have delivered. And I would thank you ahead of time for your cooperation on this. And with that, I'd like Laurie to come up.
Well, I have to say, it's an honor to be here today, and I really appreciate all your positions and the backgrounds that you come from. This also made it particularly challenging for us to decide where to start on our explanation and discussion on brain development. So we decided to start from the beginning, basically, to explain a little bit about brain anatomy. Is that better? Sorry, thank you. So based on the diverse audience that we're addressing, we decided to provide some basic background on brain anatomy and especially brain development of adolescents. So we'll build you up to the point where Dr. Sisk will reinforce what I present with research that's documents these things in validated studies. So with that, there we go. All right. As Dr. Onaga said, my name is Lori Hoisington, and I am an assistant professor in human development and family studies. I have a background in clinical healthcare in magnetic resonance imaging, so I come from an unusual background for the department, but also one that allows me to integrate the hard sciences with social science. I decided to advance my educational career in behavioral sciences so I could understand the interaction that I was seeing on functional magnetic resonance scans. And in doing so, I just kept right on going and ended up with a PhD in family studies. So I worked in that department. I'm actually in the other camp now, if you will, and I address brain development from the social sciences. The goal of our presentation today is to help you become more informed consumers of neuroscience research. This is based on findings that have happened in the field. We've learned that adolescent brain development is different. They're at a different stage of development than adults, and clearly they should be handled and managed differently than adults. This information is already being used to shape public policy, and it is our hope that changes will be made and that we'll reconsider the culpability of adolescents for the behavior that, is the way we're handling them now. So to this end, we'll share information that we've gained about the adolescent brain development through neuroscience in hopes that this will facilitate research to policy. The images on the screen reflect very thin slices through the human brain. And this is important because we have to preface the study of neuroscience and functional imaging with the knowledge that we can acquire information about very localized spots in the brain, the activity that is occurring in those spots. The image on the left is an image of the brain from below, an axial image. The image on the upper right is looking at the brain from behind, and the image on the bottom right is an image looking from the side. It's important to understand that we have the ability to view images in these different directions because we literally have to create somewhat of a three-dimensional view of activity when we record it with functional imaging to understand exactly which part of the brain is functioning during a particular exercise within a scanner. The brain is made up of two primary types of material, if you will. I'm sure you're probably familiar with the term gray matter and white matter. The gray matter overlays the outside of the brain. It's a surprisingly thin layer of cells, and these are actually nerve cells, that are only 2 to 4 millimeters thick. But believe it or not, these cells comprise approximately 40% of the brain. And the reason this happens is because the brain has a lot of infoldings and convolutions, a lot of valleys and hills, if you will. And this layer of the cortical layer, which is the layer of the gray matter, lines all of these little infoldings and outfoldings. Under the gray matter is what we call the white matter. The white matter includes myelinated tracts, and these tracts are extensions of the nerve cell that carries signal to and from other parts of the body. So the majority of the brain is actually made up of the white matter, which are the tracts. There is other anatomy. There are gray matter nuclei within the brain itself, but that's outside of the scope of the discussion. It's not really going to contribute to what we're the topic for today. This is a neuron. A neuron is simply a nerve cell. You have 100 billion of these in your brain. The nerve cell it's important that we start at this because this is the building block of the nerve system and the system that differentiates an adolescent from an adult. The nerve cell is comprised of a main part, which we call the body of the cell, and then some shorter extensions that receive signal from neighboring cells. Those extensions are called dendrites. The long extension from the nerve cell, the single extension, is known as an axon, and that carries signal to other parts of the brain and body. One of the phenomena that we've learned over the centuries about the brain is that there are electrical connections, if you will, between brain cells, and those connections are known as synapses. Synapses typically occur between an axon of one brain cell and then the dendrites of the next. So typically it's an electrical chemical impulse that travels across the nerve, jumps over the axon, and then excites neighboring dendrites of other cells. This creates a neural circuit. This is how signal gets from point A to point B in the human brain. One of the phenomena that we've learned about through research is that there's an overproduction of gray matter. That is like an overproduction of these dendritic connections in a pre-adolescent. We don't understand exactly why. It may be related to hormones, it could be just genetic. But for some reason, just before puberty, individuals grow extra connections. This is known as synaptogenesis. This is an important concept because this places the adolescent in a position to be able to learn new things, to be able to change, to be able to modify their behavior. It's almost like a second chance to learn how to behave in life, if you will. And this mirrors discussions about why we should treat individuals, youth offenders at this age, maybe differently. We don't want to put them in a correctional facility where they're not being surrounded by positive influences because they're very moldable at this age. It's important that they're placed in the proper environment. The volume of the adolescent brain is highest just before puberty. Around that time, other areas of the brain also begin to mature. The axons, for instance, develop a coating that insulates them and helps signal travel much faster, up to 100 times faster. What happens in the brain, though, is that the parts of the brain that are associated with the senses become myelinated much earlier than the parts of the brain that are used for cognitive rational thinking, which is in the front of the brain. The process of myelination is important to the understanding of the adolescent brain. Myelin is a fatty substance, as I said, that coats the axons and facilitates the speed of signal, how fast the signal travels from point A to point B. In the human brain, myelination begins in the back and ends in the front. This process does not complete until an individual is in their early to mid-20s. What we have then is a setup where an individual has multiple possibilities, potential for change in the front of their brain, but this superhighway that allows the signal to conduct through the brain has not completed in the front where they need it the most. The prefrontal cortex is in the most anterior frontal part of the brain. This area functions to control things like goal setting, rational decision making, being able to change behavior as the situation changed, being able to foresee consequences for behavior. What I do today is going to cause this tomorrow. Adolescents are particularly, I don't like to use the word handicap, but for lack of a better word, they're a bit handicapped in this regard. And it's not an abnormal stage of development. Adolescence is a perfectly normal, necessary stage of development. But at this stage, the connection is not very, the connection is not well paved to the front part of the brain where they need it the most to make the decisions, wise decisions, rational decisions. This is an image of the prefrontal cortex, or a sagittal view of the brain, actually. The prefrontal cortex, you can see, is in the most anterior part of the brain. There are billions of connections between not only different parts of the brain, but also between the brain and other parts of the body. The myelin, the coating that connects these superhighways, continues to develop from the beginning of adolescence, puberty, on through to the early to mid-20s. The connections, that overgrowth of connections in the front of the brain, however, generally complete by mid-adolescence. So this is an individual, the adolescent is an individual that is basically set up, if you will, to not be able to make the choices that are rational, that we consider acceptable by society. Another piece to adolescent behavior is the emotions that accompany and drive their behavior. The amygdala is a structure in the middle of the brain that is quite well formed early in development. This part of the brain is the knee-jerk reaction part of the brain. If I see this, I'll do that. Road rage is one example of this type of behavior. With the front part of the brain controlling rational thinking and the middle of the brain controlling emotions, signal that enters the adolescent brain through sight, sound, touch, etc., has a short circuit to the amygdala. It's much easier for that adolescent to react through emotion than it is for that adolescent to react through logical thinking. It's a simple matter of distance. It's a shorter distance between the amygdala and the center that receives signal versus the center that receives signal and the area that would encourage that youth or that adolescent to choose a behavior that's acceptable. Another phenomenon that occurs in the adolescent. There's a competition, if you will, going on between the reward system in the brain and the cognitive center. Adolescents are wired to experience quick pleasure, if you will, whereas the cognitive system, again, it's a longer distance from the receiving center of information. Interestingly, the presence of peers doubles the chance that adolescents will take risks. There are documented studies, and Dr. Sisk might share some of these with you, that measure the amount of risks that a 24-year-old is willing to take compared to a 14-year-old, and even the number of risks that a 10-year-old will take versus a 14-year-old. We've learned that that's a very important developmental period of time in the early adolescence, and especially vulnerable to risk-taking if peers are present and the influence is not there with role modeling by parents or other individuals who could provide that social structure. Dopamine is a substance that's naturally produced in the brain, and this substance is affiliated with several different functions. It regulates feelings of pleasures. That's one of the most important among adolescents. but it also facilitates behavior and cognition, attention, sleep, mood, and learning. There's some controversy among experts on whether the brain of an adolescent has too little or too much dopamine. But what we do know is that it affects their brain in such a way that they require increasing amounts of stimulation or excitation in order to feel the pleasure that an adult feels. This is particularly significant if the adolescent is participating in risky behavior, because as time goes on and they repeat this behavior, it means that they require more of the behavior to give them the same fix, if you will, the pleasure fix that they want to achieve. Addictions often start through this channel, if you will. They experiment with alcohol, and it helps them achieve this level of pleasure. The next time they experiment with alcohol, it takes a little bit more to achieve that level of pleasure, and on and on and on until they become addicted through this process, this feedback system. Studies have shown that adolescents process emotions different than adults. One particular study was done with functional magnetic resonance imaging, that's fMRI, for those of you that are familiar, where individuals within a scanner were shown faces and were asked to describe what type of emotion those faces reflected. The individuals who were in the adolescent group typically described the faces in a different way than the adults. The adults could describe them as being afraid, where the adolescents would be more likely to express them as shocked, surprised, or angry. Surprisingly, though, in conjunction with this study, the activity that was recorded in the adolescent brains was primarily recorded in the area that I previously described of emotions, that's known as the amygdala. The activity that was recorded in adults during this activity was recorded in the frontal lobe, the area that is more capable of making informed, rational decisions and just processing information more cognitively. We know that the adolescent brain is not as well developed as the adult brain. This has been shown many times over through studies. Adolescents are not as capable of making rational decisions, processing mistakes, and learning from experience. We know this about adolescents. They have reduced ability to engage in logical thinking. They have reduced ability to control impulses. These are things that are regulated in the frontal lobe. That frontal lobe is just not well connected yet at that age. There is a higher risk for reckless and sensation-seeking pleasure, and individuals at this age, the adolescent, is more likely to become involved in criminal activity. We have to ask ourselves then, based on this information, do the privileges we afford to adolescents match their competence according to brain science? I think the answer has clearly been documented as no, and we've got case studies that we'll talk about in a minute, rulings that have declared that this is just not the case. Youth competency is a measure of whether youth can contextualize their action. This means when a youth is participating, an adolescent is participating in something like a crime, there are cases where individuals were charged with homicide because they accompanied an individual who committed homicide. Does a 16-year-old have the cognitive ability to know to not walk inside the store with his friend when his friend has a gun pulled out? If he stays outside of the store, chances are he will not be convicted of homicide. But the minute he walks into the store, he is accompanying that individual, and the rules change. And they change historically depending on the state. The age of these individuals being tried as adults is different. We're moving policy more toward trying to level the playing field for adolescents and hold them accountable for what they are developmentally capable of doing. Competency for adolescents it's an assumed requirement in order for them to be charged for the course of their behavior. So the real question at this point is, what are they capable and competent of doing? Are we expecting too much from our adolescents based on what we know about their developmental state at that age? Historically, we have a history of executing our youth offenders, our juvenile offenders in the United States. This is not the case anymore. It's sad to read the case studies, though. I won't try to share them at this point. There are too many of them, and it's not in the scope of this discussion, but there have been 364 juvenile offenders executed in the United States. Execution was ruled unconstitutional in 2005. This was a landmark decision ruling that changed the future for our juveniles, especially those who had already been convicted of crimes. We have over 2,500 juvenile offenders in the United States who are currently serving life without parole. There's policy and legislation that is on the table to try to change this, and some ground has been made. We've made progress toward changing this and assigning more appropriate consequences for these individuals. But we're not done yet. We're still in that process. A few landmark decisions that have been handed down historically. I'm sure most of you are familiar with the abolition of the death penalty for juvenile offenders. That's Roper versus Simmons in 2005. And that was based on an understanding about society's evolving, society itself has evolved into a state where they understand that adolescent brain development is such that adolescent offenders have potential for rehabilitation. And Justice Kennedy, he used this argument in the decision to abolish the death penalty for for juvenile offenders. A few years later, another individual entered the court system who was assigned life without parole for a non-homicide crime. That's Graham versus Florida. And in 2010, the High Court ruled that individuals who are not, juvenile offenders who are not involved in homicide crimes would not mandatorily be assigned to the death penalty, to life without parole. They took that one step further, and the court considered a case where an individual had committed a homicide. This was actually an individual that was accompanying another youth. He did not actually pull the trigger, but had been assigned to life without parole. And the courts ruled that individuals who have committed homicides, youth offenders, should not be mandated to life without parole. That should not be the only possible sentence for these individuals. In other words, the court must consider other possibilities in sentencing. After that ruling, we had to consider these 2,500 individuals who are currently serving life without parole for juvenile crime. And we're at the point today where we're arguing that these individuals should have reconsideration of their life without parole. Should we give them a second review, give them a second look, consider the crime, consider the sentence, and maybe level it, balance it a little bit better so these individuals are not serving life without parole. As far as I know, that is still in the court system, and that's currently happening. Interestingly, Michigan, Minnesota, Pennsylvania, and Louisiana are 4 states that have not applied this decision retroactively and are not reviewing life without parole for these individuals even after these rulings. So we'll learn more about that as time goes on. Moving forward, developmental science absolutely should drive the way we manage youth offenders. We know they're not the same as adults. Adolescents are clearly have the incomplete level of brain development compared to an adult. And when we consider these individuals, we have to think about assigning culpability and assessing their competence to stand trial. We have to consider how punitive sanctions will affect their behavior. We have to consider their level of development in the brain and what they're capable of as far as rehabilitation and changing their behavior. They're very moldable. Positive influences can change a youth and adolescent. And the closer they are to the time of puberty, the more likely they will be to change. Our restorative justice system assumes culpability for juvenile offenders and focuses on restitution and citizenship. In this consideration, there are several factors, though. The Mental Health America Association opposes life without parole for juvenile offenders, arguing that it's not consistent with accepted purposes that guide sentencing. I'm not going to get into the details of the 4 purposes, but those are deterrence, retribution, incapacitation, and rehabilitation. But there is a significant finding through research that we've learned, and that is that the intent of the adolescent is not the same as the intent of an adult. Their mental state is not the same as an adult when they commit a crime. It can't be the same because they don't have the same structure, they don't have the same wiring in their brain to make those decisions. And that should be taken into consideration when we decide on the consequences for juvenile offenses. With that, I open up to questions for those of you who may have them.
Is there any correlation between physical maturation and other aspects of growth and maturation?
That's a good question, yeah. Is there any correlation between physical maturation and other developmental processes that occur in the adolescent brain? And the answer is not directly, because what we have found through research is that adolescents will continue to develop the same physically, regardless of whether or not they are influenced in a negative context, regardless of the estrogen and testosterone level in the period of puberty. And the hormones do cause a lot of knee-jerk responses from adolescents. That's a factor. But the physical development remains unchanged regardless of how hormones fluctuate, for example. So we've wondered about that correlation, but it's not documented.
I was wondering about the children that start using drugs at a really early age. Does that cut, so like say they start drugs at like 12 or whatever, and by the time they're 19, 20, is this affecting their prefrontal cortex from being able to develop on an emotional level?
The question is, okay, so if an individual begins drugs around the time that they have all these extra connections in their brain, what's going to happen? Can they still change? And the argument is that the more they practice that behavior during the developmental time when they have all these extra connections, all these potential possibilities for positive change, the more they practice the drug during that time, the more difficult it will be to change later. Those connections I was telling you about, the synapses fall off. They're eliminated at the rate of 0.7% a day, I believe, during the most influential time of pre-adolescence. That's just a huge amount of change very quickly. So the earlier you can capture them when they have that overgrowth of nerve cells and synapses, the more likely they are to be changed by positive influence of behavior.
Could you speak about diet? We look at the growth hormones in red meat and what's happening with our food supply and the fast food industry, how that all plays, the role that it plays.
Yeah, that's a good question. I think one of the hormones that you're describing that are passed along through the nutrition is estrogen, and that estrogen does interact with a lot of different areas of the brain. The emotion center is one of those, it increases the excitability of individuals. It makes their flashpoint more, they approach this emotional flashpoint more quickly under the influence of hormones. So with the same input and the same interaction socially, they will blow up more quickly if they're under the influence of higher levels of estrogen. So indirectly, diet does affect the way individuals behave at that age.
When you say blow up, are you speaking about their emotions, the quick trigger to anger?
Yes, flashpoint on emotions, exactly.
I wanted you to, if you could elaborate on or if there's a correlation behind toxic stress and I guess what young people that grow up in poverty might experience in their brain development and how that might impact their overall development.
So toxic stress is probably, are you referring to the release of cortisone in the body? I'm not familiar with the exact process. Dr. Sisk might be able to answer this, of how cortisol interacts with the emotion system and brain development.
I guess just to clear, I guess that was a little bit, how young people's stress is good, but an over amount of stress in their lives, how it could have I guess a negative effect on their brain development.
Yes, yeah.
Okay.
And stress can interfere with normal brain development because they're focusing on something other than positive development. And again, it's just practicing a certain behavior. Eventually, you're going to mold that behavior into a more permanent type of behavior. Cortisol, in general, is at a high level. It's not considered to be a good thing for children or adults, but adolescents are particularly vulnerable to higher levels of cortisol just because of the rapid changes that are occurring and the risk, if you will, of practicing a negative behavior during that time. The behavior is going to become more permanent much more quickly than it would for an adult. And this also comes back to the point where we were asking, can individuals change? You know, you were asking about that. If an individual does drugs when they're younger, can they change when they're older? Sure, you can change anytime. Neuroplasticity is the body's ability to change through repeated behavior exposure. And you can do that at any point. An adult can learn a new language. A young child, though, can learn it much more quickly and easily. But an individual who practices risk-taking through drugs, for instance, can change at an older age. It's just not as easy, and it takes more time. And I think we have time for probably one more question, and I'm not going to need to turn the mic over to Dr. Sisk.
Could you explain if the social media have a lot on our children, for those that are not on drugs or alcohol, with the music and stuff that work with the negativity of negative words?
Yeah, the social media has a huge influence on our youth. For instance, in the school shootings, we find that some of the perpetrators were so grossly immersed in games such as Diablo, and I know there are a couple of these games, I have to apologize, I'm not more familiar with them, but when they interviewed the two youth when they interviewed people who had worked with the youth for the Columbine shooting, for example, they found out that the one who was the leader and his perpetrators had been so immersed in these games that he actually did written in a journal that he just lived and breathed the games, and if he wasn't playing it, he was trying to figure out how he could be acting it out in life. And that's an extreme example of social media, but the media does have a huge influence on our youth.
Can I ask one question?
Oh, sure.
She's coming.
Other than you and the other doctor and telling us this information, do teachers know this information?
We're trying to pass the word. In fact, I'm speaking in Dearborn Heights in a couple weeks to a group of parents and teachers trying to share this information.
Do judges know this information?
It depends on the individual judge. We need to make it more widespread. We need to share this as widely as we can. It's been difficult to interject the information, disseminate among that field. Brain development has remained mostly in the neuroscience, the hard sciences, more recently in the social sciences. I took the leap from neuroscience over to social science so I could help this cause. But it's taken me 4 years to get my foot through the door in a lot of these contexts. It's not an easy thing to do.
Okay, so what we need to do is learn this and then help you to pass it on. Because it seems to me that if the educational system understood this and our judicial system understood this, then there's no need to be locking up our youth like they're locking up our youth.
Right.
And we also need to understand, does this brain activity work on all youth in the same way? Or does race play a issue in how this brain develops? And why don't more people understand this so that we can help our youth?
Yeah, there are so many questions to answer and disseminating the information to help our youth. We have to just start one step at a time and methodically disseminating the information as rapidly as we can, and to involve as many professionals as possible so it's holistic. You know, the approach must be holistic. It can't just be from one perspective because there's so much involved in the context and the biological development and the nutrition, and you know, it just goes on and on. But it's a starting point, and that's why we're here today. We'll take one more question, and then after this one, we'll have to turn the mic over.
I'm a teacher, and I just wanted to make this comment. Why not make that a part of your certification? Because we're required by the state of Michigan to take a course in reading and child development. So this should be a part of a teacher's certification. That's a way of getting it to, getting our teachers, educators to know that.
I think we're moving in that direction, and the fact that I'm in human development and family studies instead of neuroscience attests to that. So with that, I'm going to turn the mic over to Dr. Zisk, and I want to thank you all for being here today.
Thank you, and I'd first like to thank Esther for the invitation to talk to you today, and thank Lori for her great introduction. The way we set this up was that I would follow up Lori's talk with some examples from the research literature that show how adolescents process emotions and rewards and so forth differently from children or adults, and kind of just reinforce with example many of the things that she has been talking about. So I want to start with some data that probably I would guess that you all are familiar with, and this is showing some statistics that that illustrate how teenagers or adolescents, basically those from 14 to 25 years of age, account for most of arrests and homicides. So on the left-hand slide, you see, so small I can barely read it myself, the arrests per 100,000 in the population, and then on the x-axis there is age in years. And so you see the peak in terms of that represent just overall arrest rate is between about 14 and 25. And then the graph on the right, it shows similar data in a somewhat different way. It's, I'm sure, difficult to read, but along the x-axis are years. So this is showing you it's going from 1900 something through present time, and then the different colored lines within that graph shows you different age groups. And so at the, let's see if I can, there's, oh good, I've got a cursor here. So these bottom lines here are under 14 and 50, and then as you see, and again, this would be in 1994-ish, so mid-1990s. The pattern is the same really regardless of what year we're looking at, whereby now we're looking at homicide offenders by age, and you can see again that this 14 to, I'm sorry, I can't even see this, 18 to 24 and then 14 to 17 by far make up the bulk of homicide offenders, no matter what year or what sort of century you're looking at. So the question is what accounts for this, and so what I'd like to share with you again is some data that depict how both behavior and brain activity of individuals in this adolescent age range, so 13 to 25, is different, and what we've learned from research on those lines. So just to sort of tell you what I'm going to be telling you, I want to go back and review just in one or two slides the neural circuits that regulate behavior control and emotion and reward, just sort of a reminder from what Lori has just said, and then show several examples, 3 or 4 examples from the literature of how behavioral and neural reactions are different in adolescence, and then talk a little bit or end with some implications for policy. So here is a picture of a brain very similar to ones that you saw in the previous talk. So we're now looking at a side view along the midline of human brain. This is front and this is back. And here are the prefrontal cortex areas that Lori talked about that are involved in executive function, behavioral control, decision making. So these are cortical structures. And then subcortical structures, so those that are deeper within the brain, include 2 areas that are going to be important in the next few slides. One is called the ventral striatum, and that's shown here. The ventral striatum is associated with reward and motivation to seek reward. And then the amygdala, which Lori also mentioned, is a primary area of the brain that's related to not only processing of emotions, but also fear assessment. She talked about that sort of short circuit or hotline from sensory information to parts of the brain that trigger fear and alarm reactions, and that would be the amygdala. Now, some people have talked about these 2 sets of brain structures as being analogous to 2 figures from Star Trek. So Captain Kirk is, so the ventral striatum and the amygdala are the Captain Kirk of our brain, whereas the prefrontal cortex, the executive control areas are the Mr. Spock part of our brain. And so Spock being the sort of analytical one, let's take our time, let's think this through, let's be rational, let's think about what the consequences of our reactions will be, whereas Captain Kirk is, no, let's just get her done. We're on it, and we're going. And so you can kind of draw that analogy between these 2 sets of brain structures. And so the data that I want to show for the rest of my talk, what I will try to make the case is that one way we can think about teenage or adolescent behavior is that in adults, we've got sort of a balance between the Kirk and the Spock. You know, they're adults, they can see both sides, and you've got a balance there. Whereas in the adolescent developing brain, things are out of balance. Kirk is on it, he's already matured, he's good to go, he's ready with that emotional reaction and risk-taking, and yeah, we're just going to get her done. And bless his heart, Spock has not yet caught up in terms of maturation during this time frame. So let's take a look at some data. First of all, let me just say that a lot of I'm going to be showing examples from 3 or 4 studies that have looked at both behavior of adolescents and adults and children, so comparing behavior across age groups. but also at the same time looking at patterns of brain activation in these same age groups as they are performing the behavior. So Lori mentioned MRI. So if any of you have ever had an MRI, for any reason, chances are likely that it was a structural MRI. So if people went in and wanted to take a picture of your brain or your body or some other part of your anatomy to get a snapshot of what it looked like at that time. Functional MRI employs the same kind of imaging, but what it does is compare, it takes that snapshot of what the brain looks like during a, quote, resting state or during some sort of control task, and compares the activity of the brain or certain structures within the brain to that same individual when they're doing a different kind of task or a particular cognitive task. So we call this basically what functional magnetic resonance imaging is doing, is assessing how blood flow and oxygen consumption change in different parts of the brain as the result of a person looking at an emotional face, doing some sort of cognitive task. And so what that does through imaging of fMRI is to highlight hotspots of neural activity that correlate in time with the behavior of the individual that's being studied. So the next few slides are going to show you behavioral data, children, adolescents, and adults, and then correlate that with hotspots of neural activity in these same individuals. So first of all, this is a study that simply is looking at how do individuals of different ages or in different age groups rate something sweet versus something salty. It's a very simple sensory task. And so what you want to imagine is people, in this particular study, there were just two groups, so adolescents and adults. So these 23 to 25-year-olds were considered adults in this study. But even just comparing these two age groups, so we have these individuals in a scanner, so typically they're lying flat on their back, but they've got access to, in some cases, a computer screen that they're being presented with stimuli. Sometimes they've got a little push button thing that they've been trained to push yes or no, or 1, 2, or 3 to rate. And in this particular case, they're sitting there and they're getting, while they're in the scanner, they're getting a little squirt of something, of either water or something sweet, sucrose solution, or something aversive, a salt solution. And they're simply asked, while they're sitting there in the scanner, to rate the pleasantness or the aversiveness of that stimulus. And so what is shown here in this slide is the rating that is given to, in this case, appetitive refers to the sucrose solution, and aversive refers to the salty solution. And you can see that in both cases, the adolescents have, to the same stimulus, have report a more intense sensory or intense perception, whether it's sweet or salty, than do the adults. So just their report of how intense this stimulus is different, just even comparing 13 to 17-year-olds and then 23 to 25-year-olds. If we then take a look at neural activity in the same experiment, here's what we find. So now we're looking at a cross-section through the brain during the scanning, the functional magnetic resonance imaging. And what's shown here, this yellow circle, outlines a hotspot of neural activity, which happens to be the ventral striatum. So remember, that's one of the Kirk areas that's associated with reward and motivation to seek reward. And what was found then is that the adolescents showed more activation in response to getting this little squirt of sucrose, sugar water, than did the adults. So their perception of the stimulus is more intense, as well as reward centers in the brain are more active in the adolescents as compared to the adults in this study. So that's response to reward or to appetitive stimuli. Let me switch and talk about studies that have used a particular task called the go, no-go task. And the go, no-go task is often used to assess how reactive an individual is, how impulsive they are, and maybe how much self-control they have. So it's works like this. Again, you got to imagine this person's lying there in the scanner, and they've got images being projected to them on a computer screen, and then they've got a button that they're instructed to push or not push. And so the way this works is that while the person's in the scanner, a series of faces is presented to the subject, the person. And there are many different variations on this, but this left-hand panel shows you one variation where most of the time the faces that are presented are neutral in affect. And the instruction here on this task is to go, or press a button when you see a neutral face. Press a button when you see a neutral face. Then the instructions are, when you see a happy face, don't press the button. And the key here is that the happy faces are rare compared to the neutral faces. So the subject is kind of getting in this habit, pressing a neutral face, neutral face, neutral face, happy face, whoa! And they've got to inhibit, in order to get a correct response, they've got to inhibit that impulse or that tendency to push. And so they have to do several things when they see that happy face. They have to recognize that a happy face, they have to suppress the tendency to push the button and so forth. And so we can talk about false alarms in this task where they push the button when they shouldn't have because it was not a neutral case. And down here is showing some images, same go, no-go task. In this case, it's a fearful face that is the no-go situation. So the next few slides are going to be from studies in which the go, no-go task was used to assess reactivity and self-control, and again, the imaging, neural imaging to go along with it. Okay, so on the left-hand side are data from now children, teens, and adults, and down here show you the actual age ranges of these groups in this study. And we're looking at false alarms, and you can see that false alarms, which again in this case are instances of pushing the button on a trial when it should not have been. So it's indication of inability to suppress an impulse or reactivity. And so you can see then that the incidence of false alarms is much higher in the teens than either in the children or the adults. And then if we take a look at activity in the ventral striatum, this is shown again here in this picture. Instead of frontal section like we saw before, now we're looking from top down. And this is where the ventral striatum would be from that plane of view. And once again, correlated with the behavior, we see that neural activity in the ventral striatum is higher in these teens than in children and adults. So we have, again, a hotspot of neural activity that's associated with impulsiveness, lack of self-control, and reactivity to emotional faces. These were data from happy faces, and then this slide shows you a very similar pattern of results when the no-go task involved a fearful face. So the general lack of impulse control applies to whether an adolescent is looking at a happy face versus a fearful face. Then in a related study, now we're looking at, again, a go, no-go task in response to fearful faces. This was a separate study, but the same kind of idea. And here we find that the neural activity, again, in the amygdala is greater again in teens as compared to children and adults. These are the individual data points here. This is the average across the groups. And now, again, we're looking at a coronal or frontal section through the brain, and you can see the amygdala very deep here in the temporal lobe. So we now have seen several examples of overactivation or higher activation of these Kirk-related brain structures related to reward and emotional processing in adolescence as compared to either children or adults. Okay, now the third example of research in this area has to do with risk-taking and the influence of peers on an individual's willingness to take risk. And this is the very sort of well-known test or task that is used to assess risk-taking. It's called the stoplight task. And so a person is sitting at a simulation, kind of driving a car, and there's a virtual reality road being projected. And the basic task is to get as quickly from the start box to the end box as you can, but you don't want to crash before you get there. You want to do it, you want to get to your destination as quickly as you can, but there are risks or decisions that you have to make along the way, and they involve coming up to a stop sign or a yellow light. And so the way that the rules of the game are constructed is that if you approach a stop sign or a yellow light and you stop, as you should, then that incurs a 3-second delay. So there's a little penalty for being safe, because remember the goal of the game is to get there in fewer seconds without crashing and burning. If the individual decides to go or run through the yellow light, well, if there's no cars coming, that's considered a success and there's no delay. They made, quote, the right call. But on some trials, and of course the person doesn't know which these are going to be, in fact, running through that yellow light results in a car crash, and that incurs a 6-second delay. So basically the person's got to decide, it's a little bit of a risk-taking gambling task. Am I going to run that yellow light, running the risk of having a crash and getting a bigger delay, or am I going to play it safe, get a smaller delay, but at least I know I'm not going to crash? Or do I go for broke and just figure I'm going to beat the clock each time? Okay, so this task was given to individuals of different age groups. Again, in this case, adolescents, young adults, and adults. And so let's take a look at the data here. So on the left-hand side, we're looking at the number of risky decisions and the number of crashes. So these are just two measures within this task that give you some sense of did I decide to go? How many crashes did I actually encounter? And we're now looking at adolescents, young adults, and adults. And this is when the individuals are doing this stoplight task by themselves. And what you can see, looking across both measures, number of risky decisions or number of crashes, that actually the adolescents are not taking any greater risks than the adults or the young adults, and they're not even having more crashes than the adults or the young adults when they are doing the simulation task by themselves. So now the experiment becomes, all right, let's bring a friend or two into the room. The friend or two, they don't say anything. They're just sitting there. That's experimental manipulation. Do you have a peer in the room while you're doing this task or not? And man, do the results change under those conditions. And so, no, sorry about that. So here are the data now with presence of peers. And you can see that when peers are present with the adolescents, the number of risky decisions goes way up, the number of crashes goes way up, and yet young adults and adults, their behavior does not change in the presence of peers. And so what these behavioral data show is that peers have an enormous influence on risk-taking and decision-making by adolescents that simply is not there once they've matured out of that adolescent age period. And then again, if we take a look at the neural activity that accompanies these risk-taking decisions, Once again, here's shown a hot spot in the ventral striatum, that reward-related structure. And here, if we, in the black bars, which you see here and here, that is the neural activity pattern in the ventral striatum when adolescents, young adults, and adults are performing a task alone. And then these gray bars show neural activity when they're performing the task in the presence of peers. So the presence of peers not only kind of makes them turn into little daredevils, but that is associated or correlated with enhanced neural activity in these reward sensation-seeking regions of the brain. So just to summarize the data that I've just shown you, we see that adolescents show heightened attention and reactivity to both reward and threat. We see that adolescents display greater reliance on these limbic emotional regions, so the Kirk regions of the brain as compared to the Spock regions of the brain. And lastly, that peer influence exacerbates risk-taking, but only in adolescence. So if we go back to our Kirk and Spock areas of the brain, what people are talking about now is a way, sort of a heuristic or a theoretical framework for thinking about these things, is that essentially during this period of adolescent brain development, you've got Kirk way out competing Spock for the individual's behavior and governing the behavior. And basically the idea is that the reason that has to do with an imbalance just a difference in the timing or the tempo of maturation of Kirk versus Spock. And so that is depicted here where this limbic region to the leftmost line here shows earlier maturation of Kirk. So Kirk's kind of uncontrolled, unencumbered by the thought process at this time. And meanwhile, it takes Spock longer to provide that more rational, deliberate, consequences of my behavior kind of thinking to come on board. And so that is sort of the way developmental cognitive neuroscientists are thinking about adolescent brain development at this time. Okay, I want to just finish then with what this kind of neuroscience research does and does not tell us about adolescent culpability or rehabilitation. I want to emphasize that, first of all, these research findings don't imply in any way that juveniles should not be held accountable for their actions. All adolescents go through these same kinds of changes and imbalance between Kirk and Spock, and not all adolescents find themselves in trouble. So it doesn't mean that we just don't simply hold them accountable for anything that they do. That's not the message here. Secondly, it's important to emphasize that we can't just go in and take a brain scan or do an fMRI study on any one individual and say, yep, this fMRI result clearly indicates that Kirk is still in charge here and Spock has yet to come on board. It's much like any other kind of correlate where, if I say, okay, so-and-so is 6 feet tall, are they male or female? Well, on average, there might be a male, but you can't use that information to predict a single thing about any one individual's gender. It's just not a good predictor, and nor is what the brain imaging looks like at a particular age, also, or in a particular situation, a good predictor of stage of maturation for that particular individual. So should not be used in that way. On the other hand, though, 3 points that I think Lori also alluded to and mentioned is that because the adolescent brain is a moving target, it is in a state of flux, there's no doubt about it. It is not yet mature. There is this imbalance going on between different executive control and emotional systems in the brain. That should be considered when punishment is meted out. Another point that was made earlier is that because the adolescent brain is so plastic, we know as developmental neurobiologists and psychologists that during periods of rapid change, that's when environmental variables can have their most effect. Even a small little thing can have a big effect if you've got a steep rate of change. So let's not forget that and realize and remember that what kind of correctional measures are taken can, if they're going to contribute toward rehabilitation, they're going to have the biggest bang for the buck right then and there. So let's get on it. Let's not throw people in prison and then 5 years or 6 years later, when they maybe are about to get out, think about, I wonder how we're going to get this person back out on the street again in a successful way. And along the same lines, correctional strategies really should involve an emphasis more on pro-social behaviors and emotional regulation that eventually will play themselves out, but can be, with that in mind, provide opportunities for that executive control system to get its act together, maybe even sooner than later. So again, with that, I'd like to thank you and really appreciate your attention today and be happy to answer.
Hi guys, I'm just gonna, if you don't mind, I'm gonna cut the Q&A off on this one just because we're heading in the middle of the session, but I know that both Dr. Hosenton and Dr. Sis are here for the rest of the forum, so corner them. I know that they have plenty of things to say to you and lots of questions can be answered. At this time, we're gonna take a little break, but our breakout sessions are all ready, and just so a reminder,